Welcome to MECH 2100 Engineering Economics presentation. In this chapter, we are starting chapter 5 in the textbook. We are looking at methods of screening projects. So as an engineer, you may be involved in making some decisions within your company on whether or not a particular project is something that you want to pursue, something that will bring your company additional profits. So we need to consider the cash flow of a project. So projects typically involve some upfront investments that then gets returned over time. So in the instance of a bank, the bank may loan money to a customer, and that customer repays the loan, and they repay the loan with interest. So in the end, the bank makes money. They receive more money back from the customer than they initially loaned out. The same is true of a company. If a company decides to invest in a project, maybe they're increasing their facilities by building a new factory, increasing production, installing a new software system, something along those lines, there is some upfront cost associated with that. They have to spend money. But the goal of that project is to increase revenue to the company in the long run. So that cash gets returned to the company over time. And so the factors that determine whether or not a project is pursued or not mainly have to do, at least from our point of view in this class, with that return on investment. And there are several different ways we can measure that return to determine, is this a worthwhile project? Is this something that should be undertaken, or would we be better off investing our money elsewhere? So one way we can screen projects is looking at what is called the payback period. So there is going to be that initial investment, that amount of money that needs to be paid, and eventually the project should generate revenues that will repay that investment. So the payback method is essentially looking at, okay, well, how long does that take? How long will it take for us to get our money back from this investment? And so if it takes too long, then the company may decide that they want to do a different project or no projects at the present time. But if it's a relatively short period of time, if it's something that the company feels is an acceptable payback period, then the project may be initiated. And there's no hard and fast rule on what that time period should be. It really depends on the company and what they need. If, for instance, the company is financially stable, they might be more willing to wait a longer period of time to see a return on their investment. They're essentially playing the long game. On the other hand, if the company is more of a startup and they're a little more cash strapped, they may want to pursue projects that will have a shorter payback period. So payback period can be a good way of determining whether or not a project is something that you want to pursue. But one thing the payback method doesn't take into consideration is the scale of the project or the profits. It's really only looking at a time period. So if you're comparing two different projects, one might have a shorter payback period, which would be good, but it may not make you as much money, as much profit, which would not be good. So it doesn't take everything into consideration. In addition, you can look at the payback period from two different ways. A conventional payback method is looking at the time that it is required to recoup your investment, and it ignores the time value of money, versus a discounted method, which does include time value of money. So it is looking at essentially the opportunity cost if we didn't invest in this particular project, we could have invested the money elsewhere and made perhaps a larger return on our investment. And so again, there is no specific time limit that is considered too long in terms of screening projects. It really depends on the individual circumstances. But generally speaking, a project is chosen if the payback period is relatively short. Let's look at an example here where we have a company that is looking to spend $1.8 million to upgrade its machinery. And the reason why they might want to do this is because the expected annual savings is $908,000. And as Ben Franklin said, a penny saved is a penny earned. So it is saving the company money, so that's just as good as adding additional revenue. It's going to increase the profit by that much per year. So when they install the new machinery, it's going to take their workers some time to learn how to use it in an efficient manner. So in the first year, only about half of that $908,000 is actually going to be realized. Then in the second year, they'll see about 75% of those annual savings. And once they get into the third year, we're going to assume that the workers will be familiar enough with the new machinery that you will be realizing 100% of those annual savings. And every project has a lifespan. That may not always be apparent at the beginning of a project. When you install new machinery or build a new building, you may think that it will last forever, but of course it doesn't. Every project has a lifespan, and that needs to be taken into consideration when choosing a project. How long will this machinery last until it needs to be replaced again? So in this particular example, we are told that we can expect a 7-year lifespan from this machinery. And we're going to introduce this idea of salvage cost. So essentially what that means is at the end of the 7 years, the machinery will be sold off. And of course, we can't get as much money for it at the end of 7 years as we spent initially. Just think of owning a car. You might pay $20,000 for it up front, and after 7 years, sell it for, I don't know, maybe half that amount, $10,000 or something like that. So that would be considered the salvage value of the vehicle. So we do get salvage back at the end. That's like an income, and the salvage value we are going to receive is going to be 20% of what the original cost was, of that original $1.8 million. So what is the payback period for this project? So here is a spreadsheet that shows the year, what the cash flow is, and then what the cumulative cash flow is. And so I am going to show you how to create this spreadsheet. So let me find my Excel here. Okay, here we go. Here's my spreadsheet. So we're going to start off with the period or year. We have year 0. That's when the investment is made. We spend the money to begin the project right away. So that's like the beginning of the first year or the end of 0 year. And then we have the first year, second, third, fourth, fifth, sixth, and 7th. This is going to be a 7-year project. At the end of 7 years, the equipment will be salvaged. It'll be scrapped or salvaged. So that's the number of years. Then we've got the cash flow. And the problem statement told us that in the first year, we would receive half of the 908, was it 908,000? Let's take a look at the problem statement. I'm going to go back to the previous slide. Yes, 908,000. Okay, so we've got 908,000. We're going to see half of that in the first year. We're going to see 75% of it in the second year, 908,000. And then after that, we're going to see the full 908,000 each year for years. Actually, hold on, I need to cut these. Control X, move down one cell, Control V. So in the year 0, nothing is happening. We don't actually save any money until the end of the first year. So half of that 908 should go there. Then we've got 3/4. Then we've got the full amount. And we will continue to see that full amount in each of the subsequent years, years 3, 4, 5, 6, and 7. So that's the net cash flow. Actually, maybe I'll call this savings. This is the savings we can expect. This is like income. But we also have investment. Okay, there's going to be some cost associated with our investment, and that is the $1.8 million. That's negative. We have to spend that amount up front. So we have to spend, I think I added too many zeros. I made 18 million. This is only meant to be 1.8 million, 1,800,000. So that's the investment, what we have to spend. This is the savings we're going to receive almost as if it were revenue. And then we do have salvage. At the end of the 7th year, we are going to see 20% of that original investment. And we'll flip the sign of that to make it positive, because that's going to be coming back to us. When we sell that equipment, we receive this money. So our cash flow, I'm breaking this spreadsheet down into a few more columns than the previous one. So the total cash flow in any given year is going to be equal to the sum of these 3 values in these 3 columns. So in year 0, it's just simply the negative 1.8 million, and then we see the savings in the years 1 through 6, and then in the 7th year we have both the savings plus the salvage value. Let's compare this to the next slides here. See how we are comparing. Yep, 1.8 million, 454, 681, 908, 908, 908, and then 1 million. Okay, so that is where these values in this cash flow column came from. Our investment, half of the savings, 3/4 of the savings, the full savings amount, and then in the last year we have the full savings amount plus the salvage. So that's what we're saving each year. And then I also made a cumulative cash flow. So I'll show you how to do that. We've got a column here for cumulative. So what this is going to be, this first value is just going to be equal to the adjacent value, the negative $1.8 million. And so we start off in the hole, and then we add this amount of positive savings or revenue to our total. So this cell is going to be equal to our original investment amount plus the savings from here. And then I can just drag this down. So what we can see here is that we had a negative, cumulative, negative, negative, and then finally in this 3rd year of the project, we went from negative to positive. So that's where we finally received our payback. It's somewhere between 2 and 3. And we can look a little bit more closely at how to calculate the exact number of years in the next video.